What if everything you believed about learning was completely backward? Imagine students singing algebra equations to lock formulas into memory, solving physics problems while walking through forests, or teaching their teachers through chaotic role-playing games. And here's the shocking part. It actually works. Across the world, educators are breaking every traditional rule of the classroom, and neuroscience and educational research are backing them up. These unconventional, sometimes downright bizarre methods are proving to dramatically boost understanding, creativity, engagement, and long-term retention. Welcome to LernXpress. Today we're diving headfirst into 10 of the most outlandish teaching techniques that genuinely deliver results. We'll uncover why these approaches defy expectations, how they ignite curiosity and deep learning, and what they reveal about how the human brain truly learns best. Get ready to have your assumptions shattered and your imagination sparked, because the future of education isn't orderly or predictable. It's strange, wild, and far more effective than you were ever taught to believe. Education has long relied on lectures, textbooks, and standardized routines, but the brain was never designed to learn in straight lines. Neuroscience and cognitive psychology now reveal something surprising. Learning thrives on novelty, emotion, movement, and even controlled chaos. When teaching breaks expectations, attention spikes, memory strengthens, and motivation follows. Unconventional methods work because they activate multiple neural networks at once: auditory, visual, emotional, and kinesthetic, turning passive information into lived experience. Studies consistently show that when students are emotionally engaged or physically involved, retention can increase by up to 30 to 50% compared to traditional instruction. What looks bizarre on the surface is often biologically aligned with how the brain actually learns. These approaches also reach learners who are left behind by lecture-only systems: creative thinkers, kinesthetic learners, neurodivergent students, unlocking potential that standard classrooms often suppress. So today, we're counting down 10 teaching techniques that sound absurd, look unconventional, and yet deliver real, measurable results. Each one is backed by research, classroom trials, or large-scale educational experiments from around the world. Let's start with the most unexpected of all. Number 1. Singing math lessons. Picture a classroom belting out songs about fractions, algebra, or geometry. It sounds chaotic, maybe even absurd, but it works astonishingly well. When math is set to music, abstract concepts become concrete through rhythm, rhyme, and repetition. Melodies act as mental hooks, making formulas and number relationships far easier to retrieve later. This isn't just fun, it's neuroscience. Why it works? Music activates multiple brain regions simultaneously, including the auditory cortex, motor areas, and the hippocampus, which is critical for memory formation. This multisensory activation strengthens neural encoding and recall. Research in educational psychology shows that students who learn number facts through songs demonstrate significantly higher retention and faster recall than peers using rote memorization. In classrooms using musical instruction, teachers report reduced math anxiety, increased participation, and a noticeable boost in confidence, especially among students who previously struggled. What once felt intimidating suddenly feels playful and achievable. Math, it turns out, doesn't need to be silent to make sense. It needs to be heard. Number 2. Walking classrooms. Forget rigid desks and static rows. In walking classrooms, students learn while they move, listening to educational podcasts or guided lessons as they walk laps, trails, or school grounds. History unfolds with every step. Science, concepts sync with motion. Learning becomes kinetic. Why it works. Physical movement dramatically increases blood flow and oxygen to the brain, particularly to the prefrontal cortex and hippocampus, regions responsible for attention, memory, and executive function. Studies in cognitive neuroscience show that even 20 minutes of moderate walking can significantly enhance focus, working memory, and mood. Movement also lowers cortisol, the stress hormone, while boosting dopamine and serotonin, chemicals linked to motivation and learning readiness. The result? Students become more resilient under pressure, better able to absorb information, and less mentally fatigued. Schools using walking classrooms report improved behavior, longer attention spans, and higher engagement, especially among students who struggle with traditional sit-still instruction. It's not a break from learning, it's learning optimized for the human brain. Sometimes the fastest way to think clearly is to keep moving. Number 3, the flipped classroom model. This one turns tradition on its head. Instead of listening to lectures in class and struggling alone at home, students watch short instructional videos at home and use classroom time for discussion, collaboration, and hands-on problem solving. Why it works? Flipping shifts. Learning from passive intake to active application. Students arrive with baseline exposure, freeing class time for higher-order thinking, analysis, synthesis, and evaluation, right where teachers can intervene. Cognitive science backs this up. Active learning dramatically improves retention and conceptual mastery, especially for complex subjects like math and science. Meta-analyses show flipped classrooms increase student engagement, improve exam performance, and reduce achievement gaps by allowing real-time feedback and personalized support. Another hidden advantage? Control. Students can pause, rewind, and rewatch lectures at their own pace, reducing cognitive overload and anxiety, something impossible in live, one-speed lectures. In short, the flipped classroom doesn't just change when learning happens. It changes how deeply it sticks. Number 4, or gamification. Now we crank engagement into overdrive. Gamification transforms lessons into experiences by layering game mechanics, points, levels, badges, quests, and leaderboards onto academic content. Instead of chasing grades, students chase progress. Why it works? Gamification hijacks the brain's dopamine-driven reward system. Every small win, earning points, unlocking levels, completing challenges, creates immediate feedback, reinforcing effort and persistence. This turns learning into a loop of curiosity, action, and reward. Research consistently shows that gamified learning environments increase motivation, time on task, and long-term retention, especially in subjects students typically avoid. Unlike rote memorization, games encourage experimentation and failure without penalty, which strengthens problem-solving and resilience. There's also a social layer. Cooperative quests and friendly competition foster collaboration, accountability, and peer learning, key drivers of deeper understanding. When done right, gamification doesn't trivialize learning. It reframes effort as play, making mastery addictive rather than exhausting. Number 5, peer teaching. Now we flip authority on its head. In peer teaching, students temporarily become the instructors, explaining concepts, leading discussions, or guiding problem solving while the teacher steps back. At first glance, it may look chaotic, but cognitively, it's powerful. Why it works? When students teach, they engage in what cognitive scientists call the protégé effect. preparing to explain material forces, deeper processing, stronger organization of ideas, and better retrieval. In short, you don't truly understand something until you can teach it. For the listening peers, explanations often land better because they're delivered in familiar language, with shared examples and fewer expert blind spots. This reduces cognitive load and increases relatability. Research consistently shows that peer instruction improves long-term retention, strengthens conceptual understanding, enhances communication skills, builds empathy and collaborative competence. It also shifts classrooms from passive consumption to active construction of knowledge, a key factor in durable learning. When students teach each other, they're not just memorizing content. They're building confidence, leadership, and metacognitive awareness. And the next technique? It takes creativity to an entirely different dimension. Number 6, art integration. Blend drawing, music, drama, or visual design into core academic subjects, like sketching cell structures in biology, composing raps about the periodic table, or acting out historical debates. Why it works? Art activates distributed neural networks across sensory, motor, and emotional systems. When students encode information visually, physically, and emotionally, memory traces become richer and more retrievable. Research in arts integrated instruction shows improved conceptual understanding in STEM subjects, stronger creative problem solving, higher engagement among diverse learners, better access for visual and kinesthetic students. Abstract ideas become tangible. Instead of memorizing photosynthesis, students illustrate it. Instead of reciting historical events, they dramatize them. Learning shifts from passive intake to embodied experience. Number 7, Socratic seminars. Imagine students seated in a circle, leading their own inquiry through open-ended questioning. The teacher becomes a facilitator, not the authority at the front. Why it works? Socratic dialogue stimulates higher-order cognition. Students must analyze, synthesize, and evaluate ideas in real time. This activates executive functions in the prefrontal cortex, particularly reasoning, perspective-taking, and cognitive flexibility. Empirical findings show Socratic-style discussions increase critical thinking and textual analysis, improve active listening and articulation, strengthen intellectual humility and empathy, build academic confidence. Rather than memorizing answers, students wrestle with ambiguity, and that discomfort is where deep learning lives. Number 8, outdoor experiential learning. Move the classroom beyond four walls, into forests, museums, city streets, or science field sites. Instead of reading about ecosystems, students test soil samples. Instead of learning geometry abstractly, they measure architectural structures. Why it works? Real-world context enhances transfer, the ability to apply knowledge across situations. Nature exposure also improves attention restoration, reduces stress, and increases intrinsic motivation. Studies on experiential education and outdoor learning show greater retention of material, enhanced observational skills, stronger collaboration and resilience, improved overall engagement. Educational models in countries like Finland emphasize play, exploration, and outdoor integration, consistently correlating with high performance and well-being. When learning is physical, contextual, and immersive, the brain encodes it as meaningful, not just informational. And we're not done yet. The final two methods push the boundaries even further. Number 9, improv theater. Yes, improvisational theater in the classroom. No scripts, no memorization. Just spontaneous role play where students embody concepts, characters, or systems in real time. Think students becoming historical figures negotiating a treaty or acting out molecular reactions, economic markets, or ethical dilemmas on the spot. Why it works. Improv forces the brain into rapid integration mode. Students must listen closely, adapt instantly, and respond creatively, activating executive function, emotional intelligence, and verbal fluency all at once. Research and classroom observations show improv strengthens cognitive flexibility and quick decision-making, builds empathy by requiring perspective-taking, reduces fear of failure by normalizing mistakes, dramatically increases participation from shy or disengaged students. Because improv is low stakes and playful, it lowers the amygdala's threat response. Learning becomes safe, social, and memorable. Students don't just understand the material, they live it. Number 10. Silent conversation method. No talking, no raising hands, just written dialogue. On shared documents, whiteboards, sticky notes, or large posters, where students respond to prompts and to each other entirely in writing. Why it works. Silence slows cognition in the best way possible. Without verbal pressure, students gain time to think, refine, and articulate ideas with precision. This method shifts dominance away from the loudest voices and creates genuine equity of participation. Educational research highlights that silent conversations improve clarity, structure, and tone in writing, encourage deeper reflection and metacognition, empower introverted and neurodivergent students, reduce social anxiety while increasing idea quality. Students engage more thoughtfully, build arguments collaboratively, and often produce more nuanced insights than in spoken discussion. In conclusion, these unconventional methods make one thing clear: education flourishes when it dares to evolve. When we move beyond rigid lectures and standardized routines, we don't lose rigor, we unlock engagement. Curiosity intensifies, confidence grows, retention deepens. Innovation isn't a distraction from learning, it's a catalyst for it. The most effective classrooms aren't the quietest. They're the most cognitively alive. Singing formulas, walking discussions, role-play debates, silent written dialogues. These aren't gimmicks. They're strategic tools grounded in how the brain processes emotion, movement, novelty, and social interaction. So challenge your assumptions. Question default methods. Experiment boldly. The classroom of the future belongs to educators willing to rethink the present. Which technique would you try first, and why? Share your thoughts below. If this reshaped your perspective on learning, subscribe to LernXpress for more research-backed, paradigm-shifting insights. Teach boldly, learn differently, transform deeply.